In 8.2, we're going to learn a second type of rigid motion that you also learned in 8th grade. They are called reflections. And so this is nothing new to you. The hardest part for most of you will be writing this in coordinate notation. The very first thing I want you to know are that reflections are rigid motions, meaning they are movements that do not change the shape of the object. This is our second one. Then the word that we're going to use today a lot is equidistant. Equidistant. The word equidistant means equal distances. Believe it or not. I know it's a fancy word. I'm going to zoom in a little bit. Equidistant means equal distances. We're also going to use the word line of reflection. This is known as, in short, it's abbreviated to the LOR, the line of reflection. The LOR is the line the reflection bounces across. The line of reflection is the line the reflection bounces across. Sometimes we're going to use 4 different types of lines, actually 5 different types of lines of reflection. The first type that we're going to use as a line of reflection is the x-axis. We're also going to use the y-axis. If you don't know which one the x-axis is, it's this one, the one that goes this way. I'll put an X next to it. If you don't know which one the y-axis is, it's this one, the one that goes up and down. We usually put a Y next to it. Sometimes we won't use the x-axis as our line of reflection. Sometimes we don't use the y-axis as our line of reflection. Sometimes we use other horizontal lines. Horizontal lines. Let me give you an example of a horizontal line. They are always, always, always y equals a number. Horizontal lines look like this. They go left and right. They're y equals a number. They could be a vertical line, which is always x equals a number. Vertical lines go up and down, in case you didn't know what vertical meant. The last example are diagonal lines. Bless you. I'm going to give you an example. I'm going to give you 2 examples, y equals x and y equals negative x. If I have y equals x, what it means is your slope is up 1 over 1 and your y-intercept is 0. So literally your diagonal lines of y equals x looks like this. It goes perfectly through the origin up and to the right. Yep.
So it would be 1, 1, and then 2, 2, and 3, 3.
Mm-hmm. So exactly where it goes through. Every x is the same thing as the y. If it's negative x, it's going to be the opposite diagonal. Instead of going up, it's going to be coming downward, going through the origin. The slope is down 1 over 1, down 1 over 1. I review these with you. They are things you should know from previous units that you're going to use in this unit. So the very first thing we're going to do is we're going to write down some directions on how to draw a reflection. How to draw a reflection. I want you to know how to do it first. The first thing we do is we draw the LOR. As a dotted line. Please label it. The second thing we do is we're going to count the distance from each point to the LOR. Count the distance from each point to the LOR. The last thing we're going to do, plot the image using primes as equidistant points on the other side of the LOR. If you can do these three things, you're going to be able to handle reflections all the time. Okay? I have a couple of examples for you. The first example is going to look like 8.2 HW number 1. These notes are for both worksheets. In 8.2, you have two sets of worksheets. You have these things called the notes, and you have this thing called the homework. This particular example is the second worksheet. The second worksheet says this. I'm actually going to show you what it looks like. It says there's a reflection across y equals -2. If you want right now, instead of drawing it out on your notes page, if you want to pull out your packet and look at the packet, that is fine to do. I'll let you do that right now. Get your packet out. Let's look at number 1. That way we don't have to redraw this, and there's already graph paper here. It's going to help us out. Yes? There's 2 right now. These notes are for 8.2. I didn't understand your question. Yes, you need a stamp. Have both of them done in order to get the stamp. Okay. So here we go for number 1. This says we're going to do a reflection across y equals negative 2. So I need to graph y equals negative 2. And if you're not sure how to graph y equals negative 2, I recommend you look back at your notes right over here. And when you have, let's see where it says it, y equals a number, that makes a horizontal line. So I need you to make a horizontal line where y is equal to negative 2. Well, where are the y's equal to negative 2? It's right here. I want to make my LOR a nice dotted line at y equals negative 2, and I label it. I also like, if you have a highlighter, I like to highlight what my LOR looks like. This is step 1 of what we wrote down in our notes. Step 1 says, draw the LOR as a dotted line and label it. That's what I just did. I took this y equals negative 2. It's a horizontal line because it's y equals, and I've labeled it. Step 2, count the distance from each point to the LOR. What that means is this. I need to count how far is Q from the LOR. I need to count, it's 1, 2 spaces. Then what I'm going to do, since the Q is 2 spaces from LOR, I need to go equidistant from the LOR that many spaces. I went 1, 2. Guess what I go again? 1, 2. This time I'm going to do it in red. This dot right here is Q prime. Q prime. It is 2 units away from the LOR. And I have to do that for each point. So now this is, what is this? X?
It's a Z.
It's a Z. There you go. That's a Z. Thank you. Z is 1, 2, 3 units away from the LOR. Always count these straight lines. Then I have to go 1, 2, 3. And so this is Z prime. Pretty simple. Okay, let's keep going. Let's go faster then. E is 1 unit away. E prime is going to be right here. The hard one is I. I is on the line of reflection, which means it's 0 away from the line of reflection. So it's going to stay there. I and I prime are in the same spot. And as soon as you get your 4 points, you can connect your dots. 1, 2, 3, 4. If you do this right, does your object look like it's a reflection over the line of reflection? Does it look to be the same shape as it was before, just flipped? Then you've done it right. Sometimes when you're doing this, you might catch yourself doing a small mistake. So this is a good time to check to see that you're doing it correctly. There's an example for you from number 1. The second example that I want to give you is sometimes is going to be like number 4. Move that up a little bit. 8.2 homework number 4. Sometimes on questions like this, your LOR is in the middle of your object. So I have a y equals negative 1. I'm going to graph that first. I go, here's my y's. My y's are negative 1. It makes a horizontal line like this. I'm going to label it. Y equals negative 1. It's where all my y's are equal to negative 1. I'm going to highlight it. And this one might confuse you because you have a line of reflection in the middle of the object. Well, how do you reflect it if half's below and half's above? It's easy. We're going to count just like we did before. Let's count the W first. 1, 2, 3, 4. How far is W from the line of reflection?
4.
So I have to go the other side, 4. 1, 2, 3, 4. This is W prime. It doesn't matter if you're above it, you reflect it below it. But what if you're below it? You reflect it above it. So I went, let's go to L. L to here is 1 unit. So then I go 1 unit up, and L prime will be right here. That's why I like to do the different colors. I am doing my reflection in red. I'm doing my original in blue. How far is I? 1, 2, 3 from the line of reflection. So then I go 1, 2, 3 for my image. Where's B going to be? Let's see, here's B. I need B prime. B prime needs to go up 2 units. And B prime will be right there. And then I want to have my 4 dots. Do I have my 4 dots? I do. Connect my dots, and I'll do this in red. And then I'm going to shade it in because some of you were taught to do that. And I'm okay with it. Ideally, you just want to look and see, does this look like the same size shape, it just reflected over or across that line of reflection? It is. It's perfect. Yep. Oh, I have one more to do with you, and I chose number 3. I did. And then we'll go to a different worksheet notes on that. If I were to do number 3, let me write that down over here. I'm also doing 8.2 HW number 3. That's my other example. 8.2 homework number 3. And I'm not going to do anything other than this problem. Let's see that. Boom, 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 boom. I have a y equals negative x, which in your notes, I told you what this line looks like. If you don't remember, let's look back at what y equals negative x looks like. It is a diagonal going downward, down 1 over 1, right? So now let's draw that line. It looks like this, going right down the diagonal. The slope is down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. The y-intercept is plus 0, so it goes through 0 in case you're wondering. This still connects what we did in Unit 3. Now there's my line of reflection. The line of reflection is a diagonal. This makes it a little harder. Not a lot harder, just a little bit. Because of one big thing here. If I want to know this distance between A and the line of reflection, I got to know it's really hard to count diagonally. But it's a lot easier to count in terms of triangles. So when I go and say how far is A from the line of reflection, this is what I'm counting. I'm counting this diagonal. I have to go diagonally on the other side. That's where A prime is. You take the shortest distance from A to the line of reflection. And if that's hard for you, then think of it like this. I can go left 1, down 1, left 1, down 1, and get to the same spot, A prime, that way. Okay, so let's look at J. How far is J? It's half of a diagonal, isn't it?
Yes.
So I go half of a diagonal to J prime. And let me put my dot and put a J prime next to it. Now I'm going to go T. T is 1 full diagonal and a half. So I have to go 1 1/2 diagonals. Here's the half and 1. T prime, oop, wrong color. Red color. T prime is there. I'm counting. If you want to see my count, it's like this. 1.5. And this is, in red, 1.5 to the line of reflection. Now all I have is S. I got to go down this diagonal. Let's count diagonals. 1 diagonal, 2 diagonals. Let me just do 3 diagonals to the line of reflection. Then I got to go this way. 1 diagonal, 2 diagonal, 3 diagonals, and that is S prime. Once you have your 4 points, connect your dots. And then we can check and see, does this look like the same shape that we had when we started, only reflected over that line of reflection? Yes, it does. So that brings us to the hard stuff. The hard stuff of this unit isn't this stuff that you just did. The hard stuff is this: coordinate notation. Some of your directions are going to say write out what you did in words. That's not this stuff. This stuff is for the backside of your first worksheet. It's for numbers 5 through 10 on the 8.2 notes. The way number 5 works, let me write that down. It's 8.2 notes, number 5. Number 5. 8.2 notes, number 5. Let me recenter that real quick. It says this. We're going to reflect AB over the y-axis. Reflect AB over the y-axis. Find A prime, B prime, and write in coordinate notation. It will tell you what A is. A is at 8, -2. B is at -3, 9. Reflect AB over the y-axis. We need to find A prime and B prime and write in coordinate notation. So visually, what's happening? Visually, what's happening is this. We have a graph, and our LOR is the y-axis. Do you know which one that is? Is it the horizontal one or the vertical one? It's this one. I highlighted it in yellow. We're going to reflect something over the y-axis. What that means is, if we have a point that's on this side, let's call it W. It's going to go over the same distance to the other side and become W prime. Right? So let's think about this. We don't actually have to draw a picture to figure out what's going to happen with this value. A prime, let me write A prime right below it. If A is at 8, -2, let's put A right here. It went to the right 8 units, down 2 units. If that's where A is, and then I reflect it over the y-axis, what's your new x-coordinate going to be? Because see, you went out this way 8 units, right? So if you're going that way, where is it? -8. And what about the y value?
-2. Stays the same.
stays the same. So the way I'm figuring it out is I'm going, oh, I went 8 units to the right. Now I need to reflect it. It's going to be at negative 8, negative 2. Let's figure that out for B prime. B prime this time is negative 3. That goes to the left and then up 9. So it's way over here where B is. And I have to reflect it over this y-axis. How far is B from the line of reflection? No.
Oh, sorry. Negative 3, yeah.
So then, where is it going to be? And then the y value stays the same. So these are our two first answers, A prime and B prime. And it says write in coordinate notation. This is the hardest part for you as freshmen. It's figuring out how do I write this in coordinate notation. Here's how we start. Just how we start all transformations. X comma y is transformed. That's what the arrow means. Moves to. XY is transformed. All the x's are going to be transformed using this rule. Think of it as a rule. This is how we write things in coordinate notation. What happened from this x to this x? What happened from this x to this x? Can you describe what happens? Times negative 1. Rachel, what would you say? Times negative 1. Can somebody say it in a different way? It's the opposite. It's the opposite sign. So that means that whatever my x is, if it's a positive, it becomes a negative. If it's a negative, it becomes a positive. We are doing the opposite. We're negating its sign. We're taking our x's, whatever the x is, and doing the opposite of that x. That's what this means. It means we're taking this x and taking the opposite of it. We're taking this x and doing the opposite of a negative 3 and turning it into a positive 3. Comma. We're taking all of our y's and what happens to our y values? So y becomes y. It stays the same. That's what that means. That's the hardest part. If you understand that, then the rest of this stuff is going to be easy. Because this is the hard stuff. I have one more example for you. It's number 6. Let me press over on this real quick. This will be a last one. The last example, and we're done with our notes. Reflect AB over the x axis. Let me recenter that real quick. Reflect AB over the x-axis. Find A prime, B prime, and write in coordinate notation. Reflect AB over the x-axis, find A prime, B prime, and write in coordinate notation. So, very similar question. The A's and the B's are the same at this point, but you're asked to reflect it differently. You're now asked to reflect it over the x-axis. So if you were to draw a picture, is the x-axis vertical or horizontal? So what I do is I then highlight what the x-axis looks like. We're reflecting over that. And then I think about where A is. A is at 8, negative 2. Let me put an A right there. if the A's over here at 8, negative 2, when we reflect it, when we go up that distance and the other way, where's A prime going to be? What's the X coordinate going to be?
Yeah, 8 there.
But what about the Y coordinate?
Change to a positive. So 2.
Do we agree with Jesus?
Yes.
Yes. He's right. Think of it like this. It went this way, so your X is the same, but your Y values now became a positive. That's how we did A prime. How do we do B prime? Same thing. B is over here at negative 3, 9. Let's just put a little dot where B is. We have to reflect over the x-axis. What's going to change? What's going to stay the same? What's going to change?
Oh, the Y.
The y's are going to change. Instead of it being a positive 9, it will be...
Negative 9.
And what about your x?
Stays the same.
Which gives you the answer to your coordinate notation. Let's write this out in coordinate notation now. X, Y, all of our x's, all of our y's are going to transform. And what happens with our x's? Our x becomes? Right, so what do I write? Our x's stay x's. They don't change. Our x's stay x's. Our x's stay x's. Our y's are going to... So how do I write it? What's changing with our y's? We went from a negative to a positive, or from a positive to a negative. What does that mean we're doing to the y's?
Negative.
Negative y, which means we're doing the opposite of that y. And that's our answer. Those are our answers. We'll stop your notes right there.